Hello friends, welcome to the first session of maths. Today we're going to look at algebra. So basic thing in algebra is an equation. You must have studied equation in your school days. So can you recall what an equation is? If you remember, an equation is an algebraic expression equated with another. An equation has constants and variables. The terms that can change their values are called variables, whereas the terms that have constant value are called constants. And what do we mean by solving an equation? Solving an equation is finding out the value of the variable, which is basically the unknown. Okay, so let's look at one example of an equation. Can you think of an example? Here is one example that comes to my mind. 5x plus 3 is equal to 6x plus 9. So as you will see, we have constants. 3 and 9 are constants. We have variables. We have one variable x. We have two terms. 5x is one term, 6x is another term, right? So we have mixture of constants and variables. We have two algebraic expressions. 5x plus 3 is one algebraic expression, 6x plus 9 is another algebraic expression, and we are equating them with an equal to sign, right? So this is what we can call an equation, and solving that equation is basically finding the value of x for which 5x plus 3 is going to be equal to 6x plus 9. Before we look into how to solve an equation, one very important thing we need to know is solving expressions. Okay, and the most important thing in solving expressions is the order of operations. You must have let's see, we have this kind of an expression. Let's say 5x plus 3 into 9 plus, let's say, 4 raised to 2, right? So this is one expression, and there is only one particular value for this expression for any given particular x. So how do we find out that value? So do we do this 3 into 9 first? Do we do this 4 into 4 raised to 2 first? Do we do this operation first, or this operation first, or this operation first? So there's a particular order that we need to follow, and this is a very basic thing in algebra. You have to follow that order whenever you are coming across any algebraic expression that has multiple operations. And what is that order? So that order is called BEDMAS. So BEDMAS is basically an acronym. It stands for brackets, exponents, division or multiplication, and addition or subtraction. So whenever you have multiple operations, we have to perform them in this particular order. And you will realize that division or multiplication are at the same level. So if you have one division and one multiplication, you can first do the division, then do the multiplication, or you can do the multiplication first, then you can do the division, because we have this flexibility, because division and multiplication is basically the same mathematical operation. Same thing goes with addition or subtraction. They are basically the same operation. For example, division by 5, x divided by 5 is the same as multiplication by 1 by 5. So x divided by 5 is same as x into 1 by 5, right? Similarly, adding 5 is the same as subtracting minus 5, that way. Okay, so let's look at one example. We have this expression 3 into 4 raised to 2 plus, in brackets, 4 minus 5 raised to 2 divided by 5 into 3. Correct. So as you will see, we'll have to use the BEDMAS rule. Why do we have to use BEDMAS rule? Because this is one expression and it has multiple operations, and we'll have to follow a particular order. So we'll look at the BEDMAS rule. BEDMAS rule says that first solve all the brackets, right? So we see that we have a bracket here, so we'll only focus on this one, right? Okay, and what do we do within the bracket? Also we have to follow the same order of operations. So within the bracket also we have multiple operations. We have a minus, we have 5 raised to 2 is another operation, divided by 5. So within the bracket also we'll try to follow this particular order, right? So the highest priority will be given to 5 raised to 2. That is because after brackets we have exponents, right? Okay, so first thing we'll figure out is the value of 5 raised to 2, which is 25. So this expression becomes 3 into 4 raised to 2. We haven't touched this part. Plus we have only made some change to this. 4 minus 25 divided by 5. So 25 is basically 5 raised to 2 into 3. We haven't touched this part also, right? So we still have the bracket. So we will have to continue working on the bracket itself. So we have 4 minus 25 divided by 5. Out of this minus and division operation, we'll select the division operation first, because that is what the rule says. So we'll perform 25 divided by 5 first, which is 25 divided by 5 is 5. So this expression becomes 3 into 4 raised to 2 plus 4 minus 5 into 3. So we still have the bracket, so we'll perform that. So 4 minus 5 is minus 1. So this expression becomes 3 into 4 raised to 2 into minus 1 into 3. Now you will see that the bracket, there is no operation in the bracket. It's just a number, right? So that means now we have to find out the priority of this operation and this operation and this operation. But we'll also see that there is an exponent that we need to get rid of before we get into multiplication, division and other operations. So we will look at 4 raised to 2. 4 raised to 2 is 16. So this expression becomes 3 into 16 plus minus 1 into 3, right? So this, we have one multiplication, one addition, another multiplication. We'll do all the multiplications first. So 3 into 16 is 48, minus 1 into 3 is minus 3. So this becomes 48 plus minus 3, which is 48 minus 3 equal to 45. So 45 is the only correct value of this expression, and we can derive that correctly if we follow the BEDMAS rule. So let's see what we need to do in order to solve equations. So the first thing here is solving equations with one variable. There are equations with multiple variables, so we'll look at them subsequently, but the basic thing to start with is solving equations with one variable. So let's revisit our example here. So we have 5x plus 3 is equal to 6x plus 9, and we need to find out the value of x, for which 5x plus 3 is equal to 6x plus 9. Now one way, a very basic way to do is just take x is equal to 1 and see if that is satisfied. Take x is equal to 2 see if this equation is satisfied. But that's not a very practical way, right? And that will take a lot of time, and also in complicated equations you may never be able to do that, right? So there is one simpler way to find out the value of x. What we do is, because we want to find out the value of the particular variable, we'll try to separate it from other terms in the variable. So that means we'll separate it from constant. So we will get all the x variables on one side and we'll get all the constants on other side, right? So as you will see here that you will see that we have two variable terms, 5x, 6x. We have two constants, 3 and 9, right? So we'll try to get all the constants on right hand side, all the variables on the left hand side, right? So what can we do if I don't want, let's say I'll get this 6x, I'll get it from here to here. Let's say what you can do is you can also try to get this 5x from here to here. That is also fine. Ultimately you will get the same value. So I'm going to show you both the ways. Let's say we have, so this is 5x plus 3 is equal to 6x plus 9. Now I say I want this 6x from here to here. Okay, so what do I have to do? This is one 6x here. I want to get rid of this, so that means I need to subtract 6x from the right hand side. Remember that any operation that you do on left hand side, if you want to retain the equal to sign, you have to do the same operation on right hand side also, correct? So what you do is you subtract 6x from here, so you'll also have to subtract 6x from the left side. So that means it becomes 5x plus 3 minus 6x is equal to 6x plus 9 minus 6x. So plus 6x and minus 6x will get cancelled, and this 5x and minus 6x together it means minus x. So we get minus x plus 3 is equal to 9. Now this 3 will get from left hand side to right hand side. So that means minus x plus 3 minus 3 is equal to 9 minus 3, right? So minus 3 operation we are doing on both sides. So 3 minus 3 get cancelled. What we get is minus x is equal to 6, which means x is equal to minus 6. Correct? Okay. Now let's see what we how did we start solving this. So we moved 6x from right hand side to left hand side. Now let's see if we move 5x from left hand side to right hand side, we'll get the same thing. Look at this. So we are moving 5x from left hand side to right hand side. That means what we are doing is 5x plus 3 minus 5x is equal to 6x plus 9 minus 5x. So we are doing this operation of minus 5x. So minus 5x and plus 5x gets cancelled. So what we get is 3 is equal to, how many x we have here now? 6x minus 5x is x plus 9. Correct? So this 9 we get from right hand side to left hand side. So it becomes minus 9. So this 3 minus 9 is equal to x plus 9 minus 9. So this minus 9 plus 9 get cancelled. So we get x is equal to minus 6. So we'll get the same value both ways. It is just up to you how you go ahead with it. Obviously the second method was easier because we directly get the value of x, whereas in the first method we get value of minus x, which is essentially the same thing, but it just depends on you how you want to look at it. So let's have a quick review of that. Okay, so we have 5x plus 3 is equal to 6x plus 9. Get all the variables on one side. So 5x plus 3 minus 6x is equal to 6x plus 9 minus 6x. In this particular case, we are trying to get rid of x on the right hand side. So what we get is minus x plus 3 is equal to 9. So 3 we move from left hand side to right hand side. So we get x is equal to minus 6. Let's look at how to solve equations with two variables. Let's take this particular example. Let's say 2x plus 6y is equal to 16. So as you can see, this is an equation with two variables. We have values of x and y, but we have only one equation. So now the question is, can we solve this equation? So let's say x is equal to 2. Let's say for example x is equal to 2. So what do we get? We'll put x is equal to 2 here. So you get 2x is equal to 4 plus 6y. We don't have the value of y, so we will just keep it as 6y. So this expression becomes, this equation becomes 4 plus 6y is equal to 16. Now if you solve this, you will get value of y as 2. Correct? Okay, let's put another value for x. Let's put x is equal to 1. So we get 2x is equal to 2 plus 6y is equal to 16, solving which we get y is equal to 14 by 6. If we put y is equal to 1, we get 2x. We don't have any value for 2x, so we get 2x as it is. 2x plus 6, the 6y becomes 6 is equal to 16. So you get x is equal to 5. If you put y is equal to 2, we get 2x plus 12 is equal to 16. That means x is equal to 2. So you will see that if you have two variables and only one equation, there are multiple solutions possible. We can have x is equal to 2, y is equal to 2, x is equal to 1, y is equal to 14 by 6, and infinite other variable solutions also. So there is no definite solution, and in such situation we say that this solution is not solvable just by one equation. But if you have another equation, that's an interesting thing which we'll see in the next slide. Let's say we have two equations. We'll start with the same equation that we saw last time. 2x plus 6y is equal to 22. No, this is a different equation, but it's a similar equation. 2x plus 6y is equal to 22. And now we have another equation to go with this. We have 3x plus 5y is equal to 21. Now the question is, can we find out the value of x and y and a definite set of values for x and y for which both these equations are true? Right, so two variables and two separate equations. will always give us one definite solution. This is something that you need to remember, but at the same time you have to be aware of the fact that if the same equation is coming twice, for example, let's say x plus y is equal to 5 and 2x plus 2y is equal to 10. Now if someone gives you these two equations and says, find out the value of x and y, you need to beware of such situations. That is because even if they appear to be two separate equations, they are basically the same equation. So you just multiply this equation by 2, you get the second equation. So beware of same equation coming twice. If there are two different equations, for example here 2x plus 6y is equal to 22, 3x plus 5y is equal to 21. So these are not the same equations. You cannot multiply one equation by some number, a constant number, and get the second equation. You cannot do that. So that is why these equations will definitely give us one definite solution. Okay, and we'll see how to get to that definite solution. We know how to solve equations with one variable. Now we will see how to solve equations with two variables. So let's look at how to solve equation with two variables. We'll look at the same equations. 2x plus 6y is equal to 22 and 3x plus 5y is equal to 21. And there are two methods to go about solving these equations, and both measures are similar. So let's look at the first method, which is called substitution. So the idea behind substitution is that we'll look at only one equation at a time. We'll try to express one variable in terms of the other variable, in the sense that let's say if you're looking at this 2x plus 6y is equal to 22, then we'll try to express x or y in terms of the other variable. We'll say x is equal to 22 minus 6y divided by 2, or we'll say y is equal to 22 minus 2x divided by 6, and then we'll substitute the new value of that variable into this variable. So then this into the other equation. So then what we'll get is we'll get one equation with one variable. So let's look at how exactly to do that. We'll say we have two options here. We can solve for x or we can solve for y. Either way is fine. So let's say I'm going to write x in terms of y. Okay, I'm going to write x in terms of y. So I get, what do I get? So I get 6x is equal to 22 minus 6y divided by 2. I'm taking it based on this equation, right? And I get this value of x and I'll put it here. So I get, substitute this value in the other equation. So I get 3x plus 5y is equal to 22, which is 3 into x, which is this new row, 22 minus 6y by 2 plus 5y, this is plus 5y is equal to 21 plus 5y equal to 21. So now we will see that because doing this substitution we have got rid of x altogether. So we have only one equation with one variable, correct? So we'll solve for y. We'll solve, if you simplify this becomes 3 into 22 is 66 minus 3 into 6y is 18y. 66 minus 18y divided by 2 plus 5y is equal to 21, which is 66 minus 8y plus 10y equal to 42. So we multiplied both the sides of equation by 2, right? So this is very straightforward now. 66 minus 42, so we got this 42 from right hand side to left hand side, and we got all the y terms from left hand side to right hand side. So this become right hand side we have 18y minus 10y. So we get y is equal to 24 by 8 is equal to 8, equal to 3. So y is equal to 3 we are able to find now. So we'll take y is equal to 3, we'll substitute it in any of this equation. 2x plus 6y is equal to 22, or we'll substitute y is equal to 3 in 3x plus 5y is equal to 21. So let's say we substitute it in this equation. So this equation we already know x is equal to 22 minus 6y by 2, right? Or if we choose to substitute in the second equation, we know x is equal to 21 minus 5y divided by 3. So either way you will get the value of x as 2. So the solution for these two equations is 2, x is equal to 2 and y is equal to 3. right? Now the only caveat we have here is that these two equations will have to be different equations. Like we saw on the earlier slide, if they have the same equation, we'll never get the value of x, or we'll also not get the value of y. So substitution method, what we do is we try to express one variable in terms of the other variable and take that value and substitute in the other variable. Okay, now we'll look at method number 2, which is a variation of the substitution method. It is very similar, but what we do is we try to get rid of one term by, we try to find out a common term by multiplication of the equations. So what we do is we see that I want to get rid of, let's say I want to get rid of x. So we have 2x here, we have 3x here, right? So if I multiply this by something, this equation by something, and multiply this equation by something, I will try to get the same x term. So let's say if I multiply this by 3 and if I multiply this by 2, I'll get 6x on both sides. So then I'll eliminate 6x from both the equation. So let's say I multiply this by 3, this equation into 3, I get 6x plus 18y is equal to 66. The second equation I multiply by 2, I do multiply by 2, so I get 6x plus 10y is equal to 42. Now what I do is, I have 6x on both sides, I'll subtract one equation from another equation. Okay. Or what we can also do is, let's say 6x on one side, so we have 6x is equal to 66 minus 18y from this equation. Also we have 6x is equal to 42 minus 10y from this equation, correct? So 6x is equal to 66 minus 18y, which is also equal to 42 minus 10y. So now we look at only this part of the equation, right? So now what can we see? We have constants and we have one variable and we have one equation. It should be straightforward to find out the value of y from here. So the value of y, if you find it out, will come out to be 3. We will obviously get the same value. It doesn't matter which method you are following, you will get the same value. You get the value of y is equal to 3. Now substitute the value of y in any of these equations and you will get the value of x. So ultimately you will end up getting the same value of x and y. How it differs from the substitution method is that we are not doing any substitution. We are just trying to find out a common term. So we choose x as the variable that that will eliminate. So we see 2x, 3x. We have 2x in one variable, 3x in another variable. So we multiply this equation by 3 and we multiply this equation by 2. The purpose of multiplying by 3 and 2 is that by doing so we'll get 6x on both sides, and we'll now get 6x on one side and try to define 6x in terms of y. We'll do it in one variable, we'll do it in other one equation, we'll do it in other equation, and both equations will equate. So we'll get one equation with y. So it's ultimately we are doing the same thing, but the method of doing is different. The next topic is quadratic equations. So the equations that we just saw were of the form x is equal to some constant. So these equations had a power of x as 1. So x raised to 1 was the term, what was the variable term, right? So there are some equations in which the power of x is 2. So such kind of equations where variables are present with power of 2 are called quadratic equations. Obviously there will be some some equations where the power of x is 3 or 4 and so on. So there are different terms for them. So for example, equations with variables of power of 3 are called cubic equations. Now the most important thing we have to know about quadratic equations is that quadratic equations have two roots. Let's look at what we mean by have two roots. Let's look at this basic quadratic equation, x square is equal to 16. Now you know that this is a quadratic equation. Why? Because the power of x is 2 and it's an equation. We have constants, we have variables, we have only one variable. The highest power of that variable is 2. So it's a quadratic equation. And basic mathematics, you know that x square is 16. That means x can take the value of 4 or x can also be minus 4. because minus 4 into minus 4 will also give you 16. So there will always be two roots, and because it is being squared and any particular number, positive number, the root of that can also be negative. So that is the reason that quadratic equations end up having two roots. So let's look at the graph of quadratic equations. So quadratic equations are always in the form of a parabola. Now a parabola is something, which is symmetrical, and it looks like a U, or it could also be like this, or it could also be like this. Those are basically in mathematics, we call them parabola. You don't need to know all this in detail, but just for you to get an idea as to how quadratic equations are represented on a graph. So let's look at this first figure. Here the equation is y is equal to x square plus 2x is equal to 1. So this is obviously a quadratic equation. Why? Because the power of x is equal to 2. X square plus 2x plus 1 is basically x plus 1 the whole square, right? And the value of x is minus 1. So that means, let's put, what we have done here is we have put y is equal to 0. Now from coordinate geometry you will know that y is equal to 0 is actually the x-axis. So we are talking about this particular line, the x-axis, right? And we are trying to find out where this parabola, that is this particular graph, intersects the x-axis. So we put y is equal to 0, we get x plus 1 into x plus 1 equal to 0, which means it has two roots again, but both roots coincide. So it's basically the same point we are talking about. That point is x is equal to minus 1. So we are talking about this point. So that is the solution of this quadratic equation. So it is not always the case that quadratic equations have two roots. They can also have one root, right? Let's, for example, here y is equal to x square plus 2x. The roots are x is equal to minus 2 and x is equal to 0. How do we know without plotting this graph? How can we find out the roots? What we'll do is, let's look at this. Y is equal to x square plus 2x, right? So we take common x, so we get x plus 2. So we equate that with 0. Why? Because we are finding out the intersection with x-axis, for which y is equal to 0. So we get either x is equal to 0 or x is equal to minus 2, right? So these basically will be the roots, x is equal to minus 2 and x is equal to 0. So if you want to plot graphs of quadratic equations, wherever that graph will intersect with x-axis are going to be the roots. Solution of the quadratic equation is where the graph intersects x-axis. So this is something that you need to understand, even if you don't really understand the details of what a parabola is, and there are higher mathematical terms like parabola or ellipse and all that. You don't need to know that much in detail, but you need to understand that solution of a quadratic equation is where the graph intersects x-axis. Okay, so let's look at methods of solving quadratic equations. One method to solve quadratic equation is by factoring. Now we'll look at this method in detail. Let's look at an example. X square plus 5x is equal to 6, and we are interested in finding out the value of x for which this equation will hold true. That means x square plus 5x equal to 6 equal to 0 will hold true. So the first thing that we do is factorize. Factorize what? So we factorize this equation such that we find two numbers such that the product is 1 into 6 equal to 6. Where do we get this 1 into 6 equal to 6? So we are looking at the coefficient of x square. Now the coefficient of x square is 1. We are looking at the constant term without any x, right? And we are multiplying them, so that becomes 6. So 1 into 6 equal to 6. So we need two numbers whose product is 6 and whose sum is 5. Why do we have sum is 5? We are looking at this particular thing, the coefficient of x. The sum is 5, right? Now what can these two numbers be? These two numbers will be, okay, numbers whose product is 6 is 1 and 6, or we can read 2 and 3. That's it, right? These are only it's 2 and 3, or 3 and 2, which is basically same, or 6 and 1. So we are only talking about 1, 6 as one set and 2, 3 as another set, right? Which of that will give a sum of 5? So we'll always get 2 and 3 adding up to 5. So we are selecting 2 and 3 as the two numbers. Now what we do with those two numbers is we'll rewrite the equation using these two numbers. So we'll split this middle term, we'll shift this 5x into 3x plus 2x like this, and we rewrite the equation. Okay, we can also write it as x square plus 2x plus 3x plus 6. Either way, it doesn't matter. Ultimately, you will get the same value or solution. Okay. Now what we do is we look at only these two terms, and we look at these two terms separately. So first and second term we look at separately. Third and fourth term we look at separately. So x square plus 3x. What do we have in common? We have common x, right? So we get x, and in bracket we have x plus 3. 2x plus 6. What do we have common? We have one second. This I think there's some typing mistake here. Okay, we have 2x here. This is 2, sorry. This is 2, right? So we x square plus 3x plus 2x plus 6 equal to 0. We look at these two terms separately. We look at these two terms separately. We get x common, x plus 3 plus 2 common, x plus 3. So x plus 3 is again common here in these two terms. So what we get is x plus 3 into x plus 2 is equal to 0, which means x is equal to either minus 2 or it is minus 3. Correct? We can put x is equal to minus 2 in this equation, and we'll see whether this is true. Let's put x is equal to minus 2, x is equal to minus 2. So we get x square is 4 plus 5x, 5x is minus 10 plus 6, 4 minus 10 plus 6 equal to 0. So this holds true. For x is equal to minus 3, we get x square is equal to 9 plus 5x, which is minus 15 plus 6. So 9 minus 15 plus 6 is again equal to 0. So both these values, x is equal to minus 2 and x is equal to minus 3, are the solutions of this quadratic equation. Let's look at another example. Okay, so we have 2x square plus 12x plus 16. Now without looking at any solution, let's try to figure out how to solve. Now you'll see that there is a coefficient here, so we'll have to consider 2, we'll have to consider 12, we'll have to consider 18, right? You always remember, check the coefficient of x square, because most of the times the coefficient of x square is 1, but sometimes you will also get coefficient of x square as a number not other than 1. So now we have to find out two numbers whose product is 2 into 18 is 36 and whose sum is 12. That means find two numbers whose product is 2 into 18 is equal to 36, okay, and sum is 12. So factors of 36 will be 1 and 36, or it will be 2 and 18, or it will be 3 and 12, or it will be 4 and 9, right, or it will be 6 and 6, right? So out of these pairs, which of them will yield a sum of 12? So 6 and 6 will yield a sum of 12, right? No other pair gives us a sum of 12. So we'll split it into 6 and 6. So we write 2x square plus 6x plus 6x plus 18 equal to 0, right? We look at these two terms separately, and we also look at these two terms separately. What do we have common here? We have a 2 common, we have an x common, right? So we have a 2 common, we have an x common, right? So we find we take this out, 2x common. So what remains in the bracket is x plus 3. From these two terms we have 6 common. What remains is x plus 3. You will see that the same term will be common. It will always be like that. when you are solving a quadratic equation. So here if you get x plus 3, here also you will get x plus 3. In case you don't get, you just verify, or maybe you know you have done some calculation mistake, you will always get the same term. Okay, so what we combine these two terms, what we get is x plus 6, x plus 3 is equal to 0. So that means either 2x plus 6 equal to 0 or x plus 3 x plus 3 is equal to 0, right? So that means x is equal to minus 3 or x is equal to minus 3. So in both the solutions we got the same number, so that means actually there is only one solution, right? So the graph of this this graph, if you actually plot, it is going to meet the x-axis like this, in one point, unlike most of the graphs that meet the x-axis in 2 points. Remember that this graph may not always be like this. It could also be like this, it could also be like this, or it could, you know, or it could also be like this. So it depends, but just for the sake of explanation, I'm drawing a very simple graph like this. So it is not this type of a graph which has 2 roots, it is this type of a graph which has only 1 root, right? So again we see that some quadratic equations can have only 1 root. General formula for quadratic equation. So there is a standard formula that we can use in case the factorization method is not yielding any results. Sometimes the numbers can be such that it is difficult to find factorization. So in those cases we use this general formula. So the general formula is like this. Let's say the quadratic equation is of the form a square plus bx plus c is equal to 0, right? So a, b and c are basically the coefficients of x square, x and the constant term respectively, right? If we write a quadratic equation in this form, the solution of the quadratic equation is going to be minus b plus or minus under root b square minus 4ac divided by 2a. Now you know that quadratic equation has two roots, right? And the 2 roots will be given by this plus or minus. That means the first root is x1 is minus b plus under root b square minus 4ac divided by 2a, and the second root x2 is equal to minus b minus under root b square minus 4ac divided by 2a. Now this formula is one of the basic formulas, so you have to know this formula. Just spend some time remembering this formula, and you will see that some quadratic equations don't have 2 roots actually, right? So they have only 1 root. So the condition for that would be if they have the same root coming twice. So that means this part b square minus 4ac, if that is equal to 0, what you are going to have is x1 is equal to minus b plus 0 by 2a, and x2 is equal to minus b minus 0 by 2a, right? So ultimately both of them will give minus b by 2a equal to minus b by 2a. So that means we see that both these solutions are same. So the one additional hint we have is that if b square minus 4ac is equal to 0, if it happens to be like that, if b square minus 4ac is equal to 0, we will see that there is only 1 root for the quadratic equation. Okay, so solution for a square plus b square plus c is equal to 0 will be minus b plus or minus b square minus 4ac divided by 2a. Let's look at this example, a square plus 5x plus c. This is the same example that we saw, right? So the solution of this was x is equal to minus 2 and x is equal to minus 3, right? Okay, now let's put this formula to use. What do we have here as a? Let's rewrite the equation in this format. So a will be equal to 1, correct, the coefficient of x square, which is 1. B is equal to 5, which is coefficient of x, and c is the constant, so c is equal to 6, correct, right? Now let's use this formula. Let's find out b square minus 4ac. So what is going to be b square minus 4ac? So let's find out. B square minus 4ac will be b square minus 4ac is equal to, what is b square, is 25 minus 4ac minus 4 times 1 into 6, right? 4 times 1 into 4 times 1 into 6, so that is going to be 24. So this is going to be 24, so that is equal to 25 minus 24 is 1, correct? Now we got b square minus 4ac. So the first root is going to be minus 1, x1 is equal to minus b, which is minus 5, plus under root b square minus 4ac, which is 1, divided by 2a. 2a is 2. The second root is going to be minus b minus under root b square minus 4ac, which is 1, divided by 2a, which is 2, correct? So what we have here is minus 4, under root of 1 is 1, so minus 5 plus 1 divided by 2. Minus 5 plus 1 is minus 4. Minus 4 by 2 is minus 2, correct? The second root is minus 5 minus 1. Minus 5 minus 1 is minus 6. Minus 6 by 2 is minus 3. So we get the same values, x is equal to minus 2, x is equal to minus 3, that we saw. Okay, so you will see that sometimes factorization method, when it is difficult, you can always you can rely on this method. This method will always give you results, whereas factorization method may or may not give you, depending on the numbers. So x is equal to minus 2 or minus 3. Three special products. These are related to quadratic equations. These special products that will help you in factorization are x square minus y square is equal to x plus y into x minus y. How do we get this? Let's see x plus y into x minus y. What do we do is we multiply these terms, then we multiply these terms, then we multiply these terms, then we multiply these terms. So this basically means x plus y into x minus y. So we get x into x first, which is x square, x into minus y, which is minus xy, then y into x is xy, and minus y into y, minus y square. So this xy and xy get cancelled, so you get x square minus y square. So this is one special product that you need to know. The second special product is x square plus 2xy plus y square is equal to x plus y into x plus y. Same thing, x plus y into x plus y. What we get is, first we get x square, then we get x plus y, x into y, then third term is this x into y, fourth term is y into y. So we will see that y is coming twice, so we get x square plus 2xy plus y square, correct? Yeah. The third product is x square minus 2xy, just the only difference is this plus becomes minus. If it is x square minus 2xy plus y square, it is x minus y into x minus y. So let's look at this, x into x, x square, x into y, negative y becomes minus xy, negative y into x minus xy, negative y into negative y will be plus y square, right? Y square will always be plus because it's negative y into negative y. So we get x square minus 2xy, right? These two are the same terms, so it becomes 2xy plus y square. So these are three special products that you will have to know. You can pause the video and try to memorize them. So what are inequalities? We just look at equations. We looked at equations of the form x plus something, some constant equal to some other constant, right? So we know what an equation is. So similarly, we also have inequalities. Inequalities are expressed with signs such as greater than, less than or equal to, greater than or equal to, like that. Okay, so you must have seen these signs: x greater than 6, 2y less than 6, 2y plus 6 less than minus 3, right? So these are not equations because we don't have an equal to sign. We are not equating the two sides. What we are saying is we are giving a relative relation, in the sense that we are just saying which side is greater or which side is less, or we are also saying which side is greater or less. So this has a specific meaning. So we are saying that a value of x x can take such a value where 5x minus 7 can also equal 30, right? So it's basically these signs, this less than equal to means it is less than, or it can also be equal to, greater than or equal to means it is greater than or also equal to. So any expressions using these signs are inequalities. And how do inequalities look on a number line? So let's say how, first of all, look in equation, a solution of an equation looks on a number line. So we have an equation, we solve it, and we get a value of, say, x is equal to 3. So how does that look on a number line? So we are basically talking about a point on the number line where x is equal to 3. So maybe this is a number line. So we are talking about a point that is x is equal to 3. Whereas an inequality is not a point, it's a range of points. So for example, if you're talking about, this is a number line, and we have 0 here, and we are talking about x less than 0, right? If you're talking about x less than 0, then we are talking about all the points like this that are on the left hand side of 0 until negative infinity. X less than 0 represents all the points that are left of 0. It does not include 0. Keep this in mind. It does not include 0. If it was x less than or equal to 0, then it would have also included 0. So there is a slight difference which can be significant sometimes. So you need to always remember whether it is less than, equal to, or it is less than. So like we saw, inequalities are basically region on a number line. X less than 0 and x less than equal to 0 will always represent two different regions. The only difference between those two regions will be that in x less than 0 we will not have 0, whereas in x less than or equal to 0 we will also include 0. So that's a very important distinction we need to understand. Let's move on. Let's look at operations on inequalities. So adding or subtracting from inequalities. Let's look at this inequality, 5x plus 3 less than minus 17. Okay, this is something like an equation, but it's an inequality. We have two expressions, algebraic expressions for both sides, and we have a relative relation given by a sign, inequality sign. So we are saying 5x plus 3 less than minus 17. Okay, now what can be, if you want to get rid of this plus 3 from one side, what do? We want to move it from left hand side to right hand side. So we subtract minus 3, right? So we do minus 3 operation on both sides, and what we get is 5x less than 20. This minus 3 and plus 3 gets cancelled. 5x less than 20, correct? And so this is how we do addition and subtraction of inequalities. So one thing that we learned here is, if you want to add or subtract anything, you just treat it as an equation. Just that, no, it is not exactly an equation, you just keep a different sign, but the way we did it in equation, we add it to the on both sides and we cancel it. So it's exactly the same way we do for inequalities also. Okay, so let's look at the other operation, multiplying and dividing from inequalities. Let's look at this inequality again. Let's see, we are looking at this inequality, minus 1 less than 5, correct? And we are multiplying or dividing by a positive number. So let's say we multiply it by 3. Okay, both the sides we multiply by 3. So on left hand side, what we get is minus 1 into 3 less than 5 into 3, correct? So what do we get? Minus 3 less than 15. So is this true? Yes, minus 3 is less than 15. So we see that if you are multiplying or dividing by a positive number, we don't really don't have to worry about this sign. We can just keep the same sign, like we are doing addition or subtraction, or the way we do it in equations. We can just keep the same sign and the inequality will still hold true. But if we are multiplying or dividing by a negative number, okay, let's see, this is, we are multiplying here by negative number, minus 1 less than 5. So let's say we are multiplying by minus 3. Minus 1 into minus 3 less than 5 into minus 3. So what do we get? We get minus 1 into minus 3 is 3. 5 into minus 3 is minus 16. Now we will see that minus 3 less than minus 15 is not true, right? And why is that? That is because when you multiply it by a negative number, this equation sign, this inequality sign does not hold true. It has to be reversed. So sign of inequality changes when it is multiplied or divided by a negative number. This is an important rule that you have to remember. And why do you have to change the inequality sign? Because obviously minus 1 into minus 3 is going to be greater than 5 into minus 3. So whenever there is a negative number involved in multiplication or division, you will have to change the sign. That is something that is very fundamental and you have to remember. Okay, now we understood how to do operations on inequalities. So let's look at how to solve inequalities. It's very straightforward. So long as you are taking care of the sign and so long as you are ensuring that you are reversing the sign when you are multiplying or dividing by a negative number, then that is the only thing that you have to keep in mind. Other than that, we can solve it exactly the same way as we solve equations. So treat inequalities as equations. Just worry about the sign only when we are multiplying or dividing by a negative number, right? So let's say we are looking at this inequality 5x plus 3 less than minus 17, and we want to find out, we will not be able to find out the value of x, remember, because this is an inequality. So x we are talking about will be a region, it will not be a value. So we are trying to find out the region of x, okay, the range of values of x for which the inequality holds true. So again we treat it like an equation. So we know we have to get rid of this minus 3 from this side, we have to move it from left hand side to right hand side. So we will subtract minus 3, we are subtracting or adding, so we don't have to worry about this sign, okay. So what we do is 5x, this becomes minus 3 here, so 5x less than 20, okay. So that means what do we have to do now? We have to get rid of this 5, so we have to divide both the sides by 5. Are we dividing by 5 or are we dividing by negative 5? We are dividing by 5 because we have a positive term here, 5x. So if you are dividing by a positive number, again we don't have to worry about this particular sign. So we just divide, we get x is less than minus 4, right? If it was minus 5x, then we would have to reverse this particular sign, correct? Just keep this in mind. So we are talking about this range where this is a number line, this is 0. We are talking about minus 4 is somewhere here, and we are talking about all values of x in this range, all values of x in this range, not including the value of minus 4. It is not including the value, it is not x less than equal to minus 4, right? So we treat inequalities as equations. The only time we have to worry about the inequality sign is when we are multiplying or dividing by a negative number. Okay, now let's look at this example. Minus 3x plus 7 greater than or equal to 31. Okay, don't worry about this sign, it doesn't really matter. What we have, first of all, what we have to do is we have to get rid of this 7. So we are adding, we will have to subtract 7 from both sides. So we are adding or subtracting a number, so this sign will remain the same. So we get minus 3, this 7 goes here, becomes minus 7. So 31 minus 7 is 24. So we get minus 3x greater than 24. Now for us to get x, we have to divide this by minus 3x. Now we have to worry about the sign because we are dividing it by a negative quantity. So we will have to reverse the sign, correct? So we divide it by, so minus 3x divided by minus 3, the sign reverses, correct? 24 divided by minus 3. So that means minus 3 get cancelled, x less than minus 8. So we get x less than minus 8. Right? So what do you mean by reversing the sign? If sign is like this, it becomes like this. If sign is greater than, it becomes less than. If it is less than equal to, it becomes greater than equal to. If it is greater than equal to, it becomes less than equal to. That way. Right? The only thing you have to remember in solving inequalities is multiplying or dividing by a negative number, in which case you have to change the sign. The next concept is absolute value. Now what are absolute values? So absolute value is basically the distance of a particular number from 0. So let's say for example you have this number line 0. we have a value here called 5, right, and another value here called -5. These are two different numbers, but you will know that both of them are equally far from 0, right? So such kind of things we represent using an absolute value. So absolute value is basically distance from 0 are always positive. When we are talking about distance, it is always positive. When we are talking about distance between Mumbai and Delhi, it will always be positive. It will be some number. It may be 0, but it will definitely not be negative, right? So absolute values are always positive, and they are written like this. They are written in two vertical bars. So absolute value of -5 is 5, right? So we saw what is the distance between -5 and 0, and the distance will be 5, right? So absolute value of -5 is 5. Absolute value of any positive number will be the number itself. Absolute value of any negative number will be -1 into that number. That is -1 into -5 is equal to 5. That way. How do absolute values look on a number line? So we are talking about two different points. Okay, absolute value of 5. What are the values of, what are 2 points where for which absolute value is 5? So we are talking about a number in the positive side. We are also talking about a number on the negative side. So we are all, when we are talking about absolute value, we are not talking about one point. We are not talking about a range of points. We are talking about two distinct points that are one is on the positive side, one on the negative side. So absolute value of 5, absolute value of x is equal to 5. We are talking about -5 and 5, correct? But when they are combined with inequalities, okay, so we know that inequalities is range of points, right? So when we have absolute values and inequalities coming together, for example, in, let's say we are talking about absolute value less than 5, right? So we have a term here which is inequalities, because we have this inequality sign, and we also have absolute value. So in such cases, let's look at what will be the solution of this. So we are talking about all the numbers, the distance of which, that means modulus of x, which is absolute value of x, the distance of which is less than 5. That means we are talking about, on the positive side, we are talking about this range, correct? On the negative side, we are talking about this range. So this is -5, this is 5, right? So let's say we take this value, x is equal to 2.5. Modulus of x is going to be 2.5. How far is this point from x? It is 2.5 units away. So 2.5 is less than 5. So that means this point should be included in this inequality. We are talking about, let's say, a point -3. What is the absolute value of -3? It is 3, and 3 is less than 5. So that point will also be included in this inequality. So we are basically talking about two regions, two regions separated by 0. We are talking about one region in the positive area, the other region in the negative area. So whenever we have inequalities and absolute values coming together, we are talking about two different regions. Let's say, for example, another example I want to give you here is x less than, modulus of x less than or equal to 7, right? Modulus of x less than or equal to 7. So that means again we are talking about 0, and as you can see, we are talking about something like, the areas of interest are going to be between 0 and 0 and 7, and the other area is going to be 0 and -7. And because we have an equal to sign, we are talking about this particular area including 7, right? So we are talking about this particular area on positive side, and we are talking about this particular area on the negative side. So modulus of x less than or equal to 7 is this area combined together that we are talking about.